In the previous section, we described the benefits of FPGA technology. By the end of this module, you will be able to describe the components of a LabVIEW FPGA system. In this slide, we see the components of a LabVIEW FPGA system. So one piece is the reconfigurable I/O or RIO hardware. Another piece is the NI-RIO driver, which is the driver to communicate between the hardware and the software. And you have the LabVIEW FPGA module as well. And the LabVIEW FPGA module is the development environment that you're going to be able to use to program the functionality of your FPGA. So the LabVIEW FPGA module is an add-on module for LabVIEW. Using the LabVIEW FPGA module, you will be able to develop VIs that will be able to execute on your FPGA target. You can also develop VIs for your host PC or real-time target to interact with the FPGA as well. In this slide, we see some examples of LabVIEW FPGA targets. All of these targets shown here have a user-programmable FPGA that you can program. The Compact RIO over there on the left is an embedded system that runs a real-time operating system and contains an FPGA. It's very rugged and it has a wide variety of I/O modules available. Below it, you see there is a single board RIO, and this is the board version of the Compact RIO. As you can see here, the Compact RIO has a rugged enclosure. The single board RIO, however, is just the board. At the top middle, you see R-Series multifunction RIO boards. These R-Series boards come in PCI and PXI form factors. You can use R-Series boards to use FPGAs on a PC or PXI system. R-Series boards have analog and digital I/O. On the right-hand side, you see the embedded vision system. This is a rugged system that offers connectivity to industrial cameras and also has a user-programmable FPGA. Also, at the bottom, you see there is a RIO instruments. Some of NI's instruments also have a FPGA that you can use to implement complex and high-speed signal processing and analysis tasks on the FPGA. And at the middle bottom, you see there's a FlexRIO. The FlexRIO product family provides flexible, customizable I/O. FlexRIO instruments consist of FPGA boards and adapter modules that provide high-performance analog and digital I/O. The adapter modules are interchangeable and define the I/O that's available. So this LabVIEW FPGA course focuses on LabVIEW FPGA programming techniques for Compact RIO, single board RIO, and R-Series applications. If you're using FlexRIO, you will typically need additional learning beyond this course because of the much faster I/O rates and requirements in FlexRIO applications. FlexRIO techniques are covered in more detail in the High Throughput LabVIEW FPGA course and FlexRIO course. So how does LabVIEW FPGA work? First, you will create a LabVIEW FPGA VI. When you run it, your VI will automatically be translated into VHDL code. Then industry standard Xilinx compiler tools are invoked, and the VHDL code is optimized and synthesized into a hardware circuit realization of your LabVIEW FPGA VI. This process also applies timing constraints and tries to achieve an efficient use of FPGA resources. The result of the Xilinx compiler tools is a bit file, which contains instructions on how to configure the FPGA circuit. LabVIEW then loads the bit file to the FPGA chip to configure it to execute what you originally programmed in your LabVIEW FPGA VI. So what are the benefits of a LabVIEW FPGA system? One, you get to leverage the FPGA technology. Also, you won't have to learn Verilog or VHDL coding or board design. You can just do it in LabVIEW. With FPGA, you can have onboard decision making, so everything is being done in the hardware. You have direct access to the hardware terminals as well. In LabVIEW FPGA, you have an extensive library of built-in functions at your disposal already, such as PID and different things like that. You can also use it to integrate with third-party IP. So you can use certain nodes to get VHDL code to go inside your LabVIEW FPGA VI. You also have tools to communicate, monitor, and control the FPGA from a Windows PC or real-time controller. So not only can you program the FPGA, you'll also be able to have a host VI that can communicate with it.